You ever feel like you're just drowning in health advice? I mean, every single day there's something new, right? A new study, some superfood. It's a lot.
It really is. You start wondering, is there a simpler way? A shortcut, maybe?
Exactly. Which is why today we're taking a bit of a shortcut, diving into some really fascinating science around something called functional water.
That's right. We've been digging into this document one of you sent over. HM Technology Woltech 021825.pdf. It's from Dr. Dick Woolert at Woltech, LLC.
Okay.
And it's a technical look at their Esperer.H2O hydration machine and the whole idea behind functional water.
So this isn't just about, drinking 8 glasses a day. This document really goes deep into the tech of this machine, the science, what makes water, functional.
Yeah, it covers how they make it, the scientific parameters they measure, it compares it to other waters, and talks about potential benefits. It's quite detailed.
Right. So our mission for this deep dive is to pull out the really crucial stuff for you. We want to help you understand what this functional water is, especially from this machine.
How it works, what the science says, and what it might mean for your health, your well-being, without getting totally bogged down in the jargon, hopefully.
Okay, let's start there. Functional water. It kind of makes sense. We talk about functional foods all the time, things designed for specific benefits.
Functional medicine, too, looking at root causes.
Exactly. So why not water that's engineered to do a bit more than just hydrate?
That's precisely the concept in the document. They define functional water as basically water that's been zapped with some kind of external energy. Could be mechanical, electrical, electromagnetic, even light. And this energy changes its physical or chemical characteristics.
Yeah.
The whole point is that these changes are meant to give functional benefits, either to us, living organisms, or even in industrial uses.
Okay, so water with a purpose, beyond just being wet. The document mentions different ways to make the stuff, but it really seems to focus on one method, calling it the most scientifically solid.
Yeah, according to this paper, electrolysis comes out on top as the most scientifically validated process.
Oh.
And given that Woltech themselves mention having over 120 man-years of experience just in water electrolysis, it's pretty clear that's their wheelhouse.
Electrolysis.
Yeah.
Okay, that definitely rings a bell from high school chemistry. Quick refresher. How does that work with water?
Sure thing. So in simple terms, you use electricity to make chemical reactions happen in water. You need electrodes, a positive one, the anode, and a negative one, the cathode.
Right.
When you pass electricity through water, H2O, it basically encourages the molecules to split into hydrogen ions, H plus AO, which are positive, and hydroxide ions, OH, which are negative.
Got it. Electricity splits the water. Then what happens with those H plus and OH bits?
Well, the positive anode attracts electrons, that's oxidation, and you get oxygen gas forming there. The negative cathode adds electrons, that's reduction, and you get hydrogen gas.
Okay.
Plus, any other ions dissolved in the water get pulled towards the electrodes, negative anions to the positive anode, positive cathodes to the negative cathode. It keeps the circuit going.
And doing this, splitting the water electrically, changes its properties. The document also mentions redox potential, ORP. Why is that important?
Yes, ORP. That's a really key measure. Redox potential tells you about the electron activity in the water. Think of it like this.
Yeah.
A positive ORP means the water tends to grab electrons. It's oxidative.
Okay.
A negative ORP means it tends to donate electrons. That's usually associated with antioxidant effects, which is generally seen as a good thing.
Right. Negative ORP sounds like what you'd want for health benefits. Now, Woltech makes a big deal about their hydration machine being different from sort of older electrolysis systems. What's the main innovation they're highlighting?
Yeah, this is where it gets interesting. They really stress that their new system energizes the water to very high levels, and this is key, without really changing the pH much or wasting water.
How does that compare to the older ones?
Well, traditional electrolyzers often split the water into 2 streams, one quite alkaline, the other quite acidic. So you'd only drink one, and the other was kind of a byproduct.
Oh, okay. So you'd get 2 different waters out, but this new machine...
Exactly. They call it one water in, one water out. What comes out is just electrolyzed water, seemingly consistent. And they even say operation's just one button. Sounds very user-friendly.
Much simpler for home use, definitely. So when they talk about this energized water, what are they actually measuring besides pH? The document lists quite a few things.
Right. pH is just one piece. They look at the amount of stuff dissolved in it, the solute, the ORP, which we just talked about, dissolved oxygen, or DO, dissolved hydrogen, DH. Then there's something they call solvent dissociation activity or ionization potential, IP. And even the water's structure, like molecule clusters and hydrogen bonds.
Wow, okay. That's a lot more complex than just pH. Now, the document has that comparison table, tap water versus electrolyzed alkaline water versus their hydration machine water. What are the biggest takeaways from that data?
Okay, let's zero in on the most striking differences. pH first. Tap is about 7.3, alkaline water jumps to 10, but the hydration machine water is only 7.6. So very little pH change like they claimed.
Right.
But look at the ORP. Tap water is positive 305 millivolts. The alkaline water is negative 137. But the hydration machine water, it's way down to negative 295 millivolts.
Whoa, that's a huge jump into the negative. Much more potential to donate electrons then.
Exactly. Then there's dissolved oxygen, DO. The hydration machine water has 12.5 parts per million, quite a bit higher than tap at 7.16, or the alkaline water at 8.13.
Higher oxygen too. What about the hydrogen?
That's maybe the most dramatic difference. Dissolved hydrogen, DH. Tap water basically has none. The electrolyzed alkaline has 0.176 ppm day, but the hydration machine water clocks in at 0.288 ppm, substantially higher.
So more oxygen, way more hydrogen, much more negative ORP, and stable pH. Quite a unique profile. What about that other thing, IP, ionization potential? What's that telling us?
Right, IP. They present it as a measure of the sort of energy state of the water, how readily it can interact. They use tap water as a baseline, setting its IP to 1.
Okay.
On that scale, the electrolyzed alkaline water is about 1.32 times tap water, but the hydration machine water, 6.45 times higher than tap water.
6.5 times. That sounds like a really significant claim about the energy level.
It is. They put some numbers on it, too. Tap water IP at room temp is roughly 10 to the minus 14. The hydration machine water is around 10 to the minus 13.
So a factor of 10 difference, roughly.
Well, they say 5x tap energy, and also mention it's more than 4 times the energy level of the typical electrolyzed alkaline water. So, yeah, significantly higher on their scale.
Okay, so this energized water means higher IP, more hydrogen, more oxygen, negative ORP, near neutral pH. According to the document, why is having more hydrogen and oxygen specifically beneficial?
Well, they highlight molecular hydrogen sighting. I think it was 400 plus reports, suggesting it helps with diseases linked to reactive oxygen species, ROS, those damaging free radicals, and inflammation.
Okay, the antioxidant angle again.
Right. And oxygen, well, that's fundamental. We need it for aerobic metabolism, how our cells make energy. So the document argues this water provides a good balance of both.
Makes sense. And before the water even gets electrolyzed, it goes through a pre-filter, doesn't it? What's that doing?
Absolutely. That's important, too. It's a multi-stage filter. You've got things like zeolite ceramics to soften water, calcium sulfide for chlorine removal, active carbon to get rid of contamination and cloudiness, carbon with silver for odors, other chemicals, and an ion exchange resin specifically for lead. So it's cleaning the water up first.
Right, starting with a clean slate before the main process. Okay, so clean water goes in, gets electrolyzed to boost energy, H2O2. Now, the big question, what specific health benefits are claimed in this document for drinking this water?
Okay, so these are product claims from the document. They mention anti-aging effects, citing a mouse study showing a 30% longer lifespan, better immune function, and scavenging free radicals. For gut health, they claim reductions in constipation, diarrhea, gas, and better calcium absorption. On a cellular level, increased hydration and improving the biological terrain.
Biological terrain, okay.
And then there are some anecdotal reports mentioned benefits for diabetes, cancer, Parkinson's, even addictive behaviors. But they are careful to label those as anecdotal.
Right, anecdotal is key there. Interesting, but not the same as controlled studies. Does the document point to any specific published research beyond that mouse study? It mentioned Fernandez and Hanioka.
It does. The Fernandez study is likely the mouse lifespan one we just mentioned. The Hanioka work looked at synergistic effects. They found that this electrolyzed water, which they called RW, seemed to boost the effectiveness of antioxidants like vitamin C, quercetin, and catechin.
Ah, so the water might help other antioxidants work better.
That's what their data suggested, yeah. They showed it on a bar graph in the document. They also noted a specific effect on vitamin C itself.
Interesting. Okay, shifting gears a bit, the document uses a couple of analogies to explain the importance of hydration. The first one is about 5 generations of hands. What's the point there?
It's a visual thing, right? Picture a baby's plump little hand versus, say, a 90-year-old's hand, which is often drier, maybe more wrinkled. The document just flat out says the difference is hydration.
Simple enough.
But the key is They mean hydration at the cellular level, not just skin deep. They give figures too, maybe about 80% water, adult male maybe 60–70%, drops to around 50% in a very old age.
That's a big drop over a lifetime. The other analogy was the fishbowl. How does that work?
Yeah, the life in a fishbowl idea. It compares our cells to fish. The water in the fishbowl is like the fluid outside our cells. The extracellular fluid, or ECF, sometimes called ECW, extracellular water.
Okay.
Just like a fish needs clean water, our cells need a healthy ECF surrounding them. If that ECF gets toxic or polluted, nutrients and oxygen can't get to the cells properly. They even call the ECF the body's largest organ by volume.
Wow, I never thought of it like that. So the environment around the cells is crucial, and this ties into how dehydration actually works at that level.
Exactly. The body tries to keep the concentration of stuff dissolved inside the cells, the ICF, and outside the cells, the ECF, balanced. That's isotonic balance.
Great.
But if the ECF gets too concentrated with toxins, becoming hypertonic, water actually gets pulled out of the cells to try and dilute the ECF. Cells shrink.
Okay.
The body is trying to fix the ECF problem, but it does so by taking water from inside the cells. That decrease in intracellular water, ICF, is what they're defining as cellular dehydration.
So dehydration isn't just being thirsty, it's water being pulled out of your cells.
At that fundamental level, yes. And they link this cellular dehydration directly to chronic disease, inflammation, and accelerated aging. Which leads to that memorable question they pose. Are you going to be a plum or a prune?
Definitely paints a picture. So maintaining water inside the cells is critical. The document also mentions the ratio between water inside, ICW, and water outside, ECW, as a health marker.
Yeah, they suggest that typically in healthy younger people, ICW is greater than ECW. More water inside the cells than outside. But in less healthy or older states, that ratio can flip, with ECW becoming greater than ICW. And then they claim that their hydration machine water actually helps increase the ICW relative to the ECW more than other waters do. They frame this as potentially reverse aging at the cellular hydration level.
That's a bold claim. Okay, so let's try and wrap this up. Based on everything in the document, what are the core benefits they attribute to this hydration machine water?
Okay, pulling it together, they list optimizing hydration, really focusing on getting water into the cells. They call it the key to wellness. Greatly increasing absorption of nutrients or supplements you put in the water.
Okay.
Safely detoxing that internal fishbowl, the ECF. Providing more hydrogen to cells, calling it the best antioxidant and vital for energy. Providing more dissolved oxygen for metabolism. Reducing inflammation and free radical damage, hence reducing aging. Making you look and feel younger, more vibrant, more energy. Even hydrating your skin from the inside out.
Quite a list.
Yes, and summarize it down to better hydration, more ICW, detoxing, flushing ECW, better solubility and permeability, more energy through synergy, and even culinary benefits like faster rehydration of foods.
Okay, so we've really unpacked this document. The core seems to be the specific electrolysis process they use, boosting energy, hydrogen, oxygen, keeping pH stable. And they connect this to a wide range of potential benefits based on their data, analogies, and, well, product claims.
It's definitely compelling. The whole idea that water could be more than just water, that it could be actively functional in our cellular environment. It really makes you think, doesn't it?
Does.
Like, if the quality of the fluid around our cells is so fundamental, what other simple things in our daily lives might hold overlooked keys to our health? Things we just take for granted.
That's a great question to ponder. If our cellular health really hinges on the quality of that internal fishbowl, what steps could you or should you consider to keep yours clean and balanced? Lots to think about there. Thanks for diving into this with us today.